live. Today we're gonna learn Elixir, the language of the future or the present. Okay, let me check if the stuff are working. All right, looks writing, looks working. Let's check in Twitch. Last time the Twitch for some reason was not working correctly. And maybe I need my cable. Let's see how much battery I have. The mobile is connected. Let's go. Let me just. Oh my goodness! I changed my camera. Was not my intention. Let me take the cable. Okay, that's connected. Now that's connected, I can open my screen source copy. Screen, that one. And then I can control my phone from my computer, and that make stuff easier because the camera is away. Oh, that's nice. Down double click. Nice. Now the camera should be working correctly. I'm gonna close that. I should be, to be honest, I should be doing my Duolingo first because probably gonna past midnight. So sorry for that, but I need to practice my Japanese. I don't know if you can hear the sounds. Let me check here in the OBS. Yeah, you can hear her. That's very low, right? America wa ookii desu. Significa América wa é ookii. Grande. America is big. Dinner, bangohan. First bangohan. So New York wa chisai. So chisai, I misclick, but chisai it's small. Toshi city janai desu. So Toshi city or cities, and janai desu means it's not. It's negation of it's not. So New York wa basically it's New York. It's not a small city. Lunch, it's hirogohan. No, I can't. I want to hear again. Okay, yoku pan wo tabemasu ka? So it's asking me, do you often eat bread? I need to speak now. So pan wa oishii desu. Basically, yeah, bread is tasty or delicious. So 毎日 4時 4時 I think it's 4 o'clock. So 毎日 it's every day. 4時 4 o'clock. Go Goro it's about, so it's half. Terebi o mimasu, so watch. So every day, probably it's I every day watch TV around 4 o'clock. Oh, I miss.
毎日4時頃テレビを見ます。毎日
Wait, 毎日 4時 4時 is 4 o'clock. What? Wait. I watch TV. Oh, okay. I watch TV 4 o'clock every day. Around. Oh, I miss around now. So I watch TV around 4 o'clock every day. Oh. Bye mistake. Okay, I finish. So we can go to the live stream now. All right. Let's send the gift for Lucas. Talking about Lucas. Lucas is doing 30 days of streaming, studying blockchains. Right? So yeah, I missed my streak. I was with the 150 days. Right. So let's close that here and let's go back to Elixir. But before, so go check it out, Lucas. It's called Olive Math for mathematician. And he's doing live streams every day, learning blockchain, but it's in Portuguese. I don't know if you can use subtitles in the live stream, but probably you can use subtitle later. But they have a lot of slides, so it should be easy to understand. I think it's the slides in English. I'm not sure.
Vai entender.
Yeah, you have a lot of words in English. No, that's in Portuguese, I think. Yeah. Anyways, yeah, check it out, his channel. So what's the motivation to learn Elixir? I was reading the book called Data Intensive Applications, and I went in the first chapter yet, but I started reading and I get very curious about how application as WhatsApp and Discord are using Elixir, because first time I heard about Elixir was not Elixir, it was Erlang language. So Elixir, I think that video kind of explained that here.
Languages.
Yeah, we have Bean languages. The Bean, it's a VM, like the GVM for Java. The GVM can run Java, can run Scala and Kotlin, I think. I'm missing somebody. Groove, maybe? I don't know if it's Groove is language. Groove it still is it's a language. Let's see if we have Groove here. Yeah, Groove is a language. Yeah, so Groovy, if I'm not mistaken or crazy, yeah, exactly, Java. So we had it's still a thing, Groovy. So old. Groovy Lang. Yeah, so all that stuff run on top of GVM. It's a virtual machine. And the virtual machine, as they said, they have a simulate a computer on top of your computer to make easy to do optimizations or portability cross platforms. Like you can run in one application you build once in multiple platforms as Android, as Linux, Windows, Mac OS, CentOS, and so on. And a long time ago, I think around 40 years ago, the telephony company was dealing with a lot of requests. Let me go dark mode. A lot of requests for calls, right? For telephone calls or messages. And then they create Erlang. Let's go here. Erlang. That's in Portuguese, but I can find the English here easily. Maybe I can go EN here. No. Why? Because it's Portuguese here? Come on. Yes. So the guys created it early, 40 years ago. Look at that. I was not here in that planet 40 years ago. And yeah, they created for telecom, how they said in the past. Now we don't use telecom anymore. That's telephone communications. Yeah, created by Ericsson. And the principles of the Erlang OTP, that's open platform, they call runtime system. It's kind of VM. I think it's the same, because the runtime, it means that you have like the bytecode running in runtime on top of something. And they create the system that need to be distributed, fault tolerance, soft real time, highly available, non-stop application in hot swapping. Hot swapping is crazy. And hot swap is ability to change something without restarting. For example, in the past, we have some motherboards from desktop computers where you can like hot swap the memory. You can just plug more memory in the computer without need to restarting the computer. Mostly used for servers. But I had I think it's Asus motherboard that has that feature where I could like put or remove. I think remove it's not possible. No, I think it's removing was possible too. Probably depending on the in the system, because they need to dump the memory from files and then do the hot swap with a little lag. But adding it was just very cool. And then, because I was reading the book about designing data intensive applications, they said that the future now, so that I think the book has 10 years ago, 10 years old now or more. Yeah, 9, right? The future now for application it's be data intensive and not CPU intensive. And you see the big datas, for example, and now with the AI, that should be more and more intense. Data flowing, terabytes and yottabytes of data needing to be processed very fast. And then I found, I think it was the year was 2008, no 2000. Wait, I think it's 20. No, it's, maybe 2020 or 2018. 2018. I starting a project where I decide to use Ijad. How to, I don't know. Yeah, Ija bird. I don't know how to spell that. So I use that and I need to learn Erlang. So that was 6. No, need to be more. It's more than 7. Okay, we are here, right? So need to be less than 8. Yeah, so it's 2016. So 10 years ago, I heard about that one. Yeah, you can see the initial release was 2003, and I heard that for the XMPP protocol, the Extendable Messaging Presence Protocol, that same protocol used by WhatsApp for messaging and many others messengers protocols. I heard that that's the way to do. But then I need to learn Erlang, and Erlang it's not a beautiful language. It's terrible language, Erlang. So Erlang it's not pretty. It's very confusing. First, it's a functional language. So it's not, for people that's not used for functional, it's already something different. But then get worse. For example, look at that. Like, what the fuck is that? Like, person, name, first, then Joe, last Armstrong. Like, what the hell? Then we can like extract from person only who. And then I need to do the same structure. I think in the Elixir you need to do the same maybe. But yeah, it's very tough coming from other languages, and we have worst. We're gonna check it out here. Something like that to receive. I even don't remember what's the notation for this means. And yeah, so we have like, I think it's guards, right? Yeah, it's a function definition with the guards to do overlapping. No, it's overrides, right? We have 2 functions, and that I want to be executed only when that was true. Otherwise, execute that one. So we are overriding. No, it's not overriding. Overloading. Yeah, you are overloading the functions. 2 functions the same, but different. And yeah. So yeah, we have records. I think in Elixir we don't have records anymore. I think it's more transparent now. Yeah, we have the symbol here for what's this? What it is? I think it's called record, but a kind of tuple or maps. Then we have as functions and so okay, but it's, I promise you, it's very tough to understand Erlang. But I built the project. I spin up the server. I didn't know how much. I didn't know how much or what exactly I was doing uh, in the language, but I was able to modify a little bit there and configure and run the project. And because one node was enough to run a lot of users, I didn't need it to do a lot of DevOps stuffs in that year, in that time. How that's working today? It's, yeah, I use chats. I think it's the chats groups. Yeah, groups is called MOOC. Oh, now gonna be very cool if I can convert that all to Elixir. It's gonna be fun see that happening. All right. Well, 21 minutes here. What I want to show you is what I built with Elixir, and I built some cool stuff, and that I want to show you. All right, so let's resume this to history. It's basically one Brazilian guy, José Valim, started studying Erlang and decided to create a language called Elixir to understand in deep how Erlang and the Beam VM and OTP works. And because he was from Ruby community, he loves Ruby syntax. He got inspired for that. So yeah, the language has 14 years ago, 30 years ago. It's much more beautiful language, modern language than Erlang. So yeah, you can see here strings. Like it's not string, it's kind of bytes. It can be byte strings. You can like range, but auto you can do that also there. That's common. Sorry. So we have functions. We have a model. In a model, you can have multiple functions. That's the private functions. And here is the guards, right? And so on. So it's much more simple language to see, understand. We have here the pipes. So because it's a functional programming language, you have like gonna pipe exactly as we use in Rust, right? You doing the transformations and contain functions, because functional programming don't like mutate data, they like immutable data. So you always get output from one function and pass another to keep doing your stuff. All right. All right. Yeah, there's a function. And then they have the receive stuff where basically we can compare that as channel for Go language, or kind of channel for Rust, and other languages also use a channel. I think Java in some level use channels. I think Python also use it. It's not channel, the name for Python. Don't remember the name now. But I think it's event something. But basically it's a way where two threads communicate across. It's basically that. Yeah, you have two process. It's not threads process. You have two process. They need to communicate, and they can communicate async or sync. And receive is the way to listen. Yeah, you can see here. Elixir relies on actor model for concurrence. So actor model is cool stuff too. And I think drawing is gonna be cool. I need to help for the Wikipedia to remember some stuff, because the last time I studied actor model was a long time ago. And I don't remember. And the idea is learn. So yeah, computer center mathematical model or concurrent computation. I don't remember where I saw first time actor model. Where? I don't remember. Okay, let's see. That's actor as the basic building block of the concurrent computation. In response to a message it receives, an actor can make local decisions, create more actors, send more messages, and determine how to. I think it was something in Java, because the language that I most learned in deep threadings and concurrence and parallel stuff was Java in the past. Java has some kind actor model. All right, and send more messages, determine how to respond to next message received. Actors might modify their own private state, but can only affect each other indirectly through messages, removing the need for lock-based synchronization. Yeah, so the lock I learned a lot and use a lot. So the difference, I think I can draw now. I remember some stuff. I want to see what the Claude says about. I think I remember some. Maybe it was RX something framework for Java. Oh, maybe it was Waka or virtual threads. Java 1.6. Yeah, I know. It's very old. Maybe it was Jetlang. He said that the the problem I am stuck in the Java 1.6 in 2025. Yeah, I don't remember. It's too long time. Anyways, or maybe I'm confusing with another stuff. And okay, the actor model originated in 1973. This is being used both as a framework for theoretical understanding of computation and theoretical base several. So I'm studying Elixir about around, I think, I don't know, 4 or 5 weeks now. And I watch a lot of videos, and I heard a video about one guy said how simple Elixir clicking in his mind, because it's act as humans. And I like the way he says. And basically he said he's saying about the actor model. So normally when we draw actor models, we draw, I don't know why, but we draw as a stick guy. Don't ask me why. Maybe because it's actor, right? It's an actor. It's acting. I don't like this color. No, we need a clean, wait, need a clean head, right? And group, let's duplicate, and the actor model, like he said, works with interaction with messages. Why that's so slim? Oh. Here, I don't know why it's because that's too big. Yeah, ScullyDraw has some. It's not infinite. They don't resize the arrows. They have some limits. So that's the act. Oops. That's one actor. That's another actor, and they are working together, passing messages. But that kind of actor model is not restricted to one or two people. They can be like in the distribute way where they connect across multiple actors. Let's put one guy talking with everyone, maybe, or not. Okay, let's put that guy on that. Yeah. So we have like a mesh or network of actors talk for others. And the important part here on that model is they have like a state, or we can call memory, or context, or anyways, where we can hold information, right? And we can call that variables. And why I cannot type here? I can type, but it's the color. Maybe I want, no, I want the box transparent. And then I want the text with some color. That's white. Wait, no, it should be have black. What's black? That's black? Oh, because I'm in dark mode. Oh, that's reversed. Yeah, so we have here some private state, how they said here in the Wikipedia. And they are allowed on to change that. In fact, for Elixir, that's it's even more restrict. That's immutable. That's a characteristic from functional languages. Immutable, right? What? It's not right. It's 2M. Oh, it's 2M. Because in the functional language, you don't want one function doing some change behavior or change information, because you lost control and clarity and a lot of other properties for mathematicians that want to express functions as they are writing mathematical expressions, right? And I'm saying that about Haskell, for example. That's a famous pure functional language that's not too much useful for applications. But anyways, so Elixir has that property. Rust, I think it's Rust is not considered a functional programming, but you can do a kind of functional program on that too. And they have the immutable concept. All languages kind of have until you use constant, right? Like you set for the register on the memory. Basically, I don't want to reserve that space in memory, and don't worry because I don't want to change that data anymore. So you can put that in the region where I don't need to write too much, but I'm gonna read a lot. Anyways, right. So let's finish here. So we have a history that's for another day, with more time. And the fundamental is concept. The actor model adopts the philosophy that everything is an actor. This is similar to everything it's an object philosophy used by some object-oriented programming. Yeah. Java, it's like the OOP language, right? And that's something I did for a long time in my life. OOP was fun, but I had a lot of problems too with that. Basically, locking process. So here in the lock-based synchronization, we have a lot of problems because OOP have all kind of containers. We have a lot of design patterns to work with OOP, and then we need to use lock for synchronize all that objects. Yeah, very cool that one. They call for semaphore, the thread blocked being locked, be atomic or not, test and set. Yeah. So lock, it's very simple. Linux use locking with files. So you can also see in the IDE, right, with PNP and EPM, you see a file called .lock. It's not kind of lock thread per se, but it's kind of the same concept where you write in a file because you cannot write in two processes cannot write the same file at the same time. So you can use that for make sure that other process need to wait until you finish. So you use the same lock process for threads too. I'll call mutex from mutual exclusion. Very cool, right? Mutex. Yeah, I heard a lot of mutex. Was very difficult to understand in the beginning because threads is confusing itself, and each language has a way to implement. But after you get, yeah, deadlock, for example, it's something that happened a lot as a problem where basically deadlocks it's people just forgot to release the lock because you need to lock and release. You lock and then you say, okay, I finish the work here. I'm gonna free for other people use, but for some bug or problem in your code, you never get in the point where you free the lock and then you have a deadlock. They have some example in deadlocks. Yeah, exactly how I said. It's about releasing the lock. And but it's funny because if you ask me, live lock, for example, I don't know what it is. It's kind of the opposed. Live lock similar to that, except that the states in processing the live constantly change with regard to another non-progressing. In connection with the examination of the airline booking system, live log is a special case of resource starvation. The general definition only states that a specific process is not progressing. Oh, I see. So live log is a risk with some agreement that detect recovered from the log. If more than one process take actions, that log detect. So that's a lot of complications for because we not using actor model. So that's a lot of stuff you need to learn for not actor model that here we don't need it. It's something that I wish to learn a long time ago before suffering too much with threads and locking stuff. Right. So okay, here in the Elixir we have a spawn. I think it's for create a process, right? Yeah, kind of threads. The spawn, it's the name used in a lot of languages to create threads. I think you have spawn in Python, you have spawn in Java. I think Java is join, right? I don't know if it's still join. But the concept, yeah, spawn is like create something, appear from nothing, from air. So here we create a function like anonymous function where they call area loop function and here Elixir is returning the result. They create a PID with 0.0 PID is process ID. Also you can create like that. You can Paul, you can go to object and the function, and that's called like atomic something. It's like it's a constant. You can create like that. And I think it probably that's the arguments. What is this then? So that's a module. Yeah, so that's the module function arguments. Send a message to the PID that you match the pattern in receive statement. So the pattern is called the match pattern from Rust. You can like cases. Here we call send and PID, it's a variable, and send that JSON with the atom like a constant called rectangle and the do tree. And the function gonna receive that here because you see the function don't have arguments, but they can receive messages. And they receive the JSON. I'm gonna call JSON, but it's not a JSON. It's kind of map tuple. And basically here is using like match pattern, the same way using Rust, to say when you find that one received, do something like that. Otherwise, if you receive circle error, do like something that. Here is a put, like it's print the output. And we can test that, I think. If we go, wait, here. Let's go. What? How to open Elixir? Just forgot. Wait, you don't. It's mix. It's the tooling. What? It's Elx? It's not Elx. Oh, wait. I just forgot. That's the problem to use too much AI. Okay, let's go mix EX. Oh boy. Yeah, so if you open here EX, interactive Elixir, Yeah, I need to type more. So we can paste here the code. They return the module, and now I can call the function. So if I run here, they're gonna create a new, I think they're gonna create a new process. Yeah, they created. So they create a new process here, and with 116, and they create two, right? Because the code there. Then they send a message and get return 6. So they did the operation. So if you go like send speed and circle, in the circle we put, I don't know, 50. We should have the area for the circle. Very cool, right? And the cool part here is we can see the, I think it's observer start. Yeah, so observer start, it's where I can see all the process. So you can see here we have 76 process. We have atoms. Atoms is like the constant. It's not constant, but it's kind of constant, unique variables. And also you can see here the PIDs. So if we find maybe it's too little, I cannot zoom in that anymore, unfortunately. But if we go here, we have two PIDs. I don't know if it's already dead. Maybe it's already dead. 1670. I don't think it's living longing, but I should be able to see they created here. We have another way to see them. It's like that. Yeah, I don't think it's alive anymore. I think it's dead. But I think if I spawn another, where my process, they get increased. Yeah, they got two more process. Can here 16, yeah, so here 16 and 17. So we have area loop. We have one reds. I don't remember it's reds. I read about. I remember they said something about the counter, unique counter. I think it's the reds. We have the memory used, and I think it's message QE here. And also we can see my system. For example, I have the scheduler. So basically my CPUs, I have 12 CPUs. I watched a cool video explaining how the scheduler works and put the process in line. And I have a curious to build something like that in Rust or go just to see how that gonna works. But yeah, so that's the CPU. They have some dirty CPUs. I don't remember the explanation for dirty. I think the dirt was where they flag. I don't remember. I remember they flagging something. I don't remember why. I need to rewatch the video where they explain that. Some DEFCON. And here they call carrier size, carrier utilization because it was used for that, right? Telecom application. That's the memory used. It's very little. And we have the supervisor. We have the pry for debugging. They'll have the gene server for create kind of servers like APIs and website is right. So let's continue here. And so yeah, so they have also agents. Agents is a process that keep track of some changing value. So create an agent with agent star link based on a function. The initial state of the agent will be whatever that function returns. So we create a start links here, and also I think you can see in the observation link between process, and yeah, you have a function that return red and green. It's array, a list array, and they return OK, and they return the agent itself. So agent get takes agent name and a function that get passed to the current state. Whatever that function returns is what you get back. So the get, they pass a function called colors. Getting colors, returning colors. You're gonna return red and green. And to update the agent state the same way. Colors. I'm sending colors for you. I want to put blue and keeping the colors there. Right. And we have also a cheat sheet here. Oh, it's a PDF. Oh, I like that one. Oh, that can be very useful until I get used. For example, that one is very useful. That one is very useful to span a lot of nodes. Yeah, so what I did so far to finish the live, because it's almost 1 hour, I have application called Capture, right? Let me see if I take here. Here, I have a Cap2, the official site, and basically that it's my project that transcribe long videos in chapters, because I do normally live streams for 4 hours and more, and that's a way to people discover the content. And the first time I did that, I wrote that in Tauri app using Rust as alternative for Electron, because Electron is slow as hell. So I use Tauri. We can create small, fast, secure cross-platform applications. Very nice. It's very cool. Like look at that. Like we can create an app as 600 KB cross platforms. It's insane using Rust. So I love Tauri app. So I create a big application. So Tauri, it's exactly as Electron, where you can use any front end as React or Svelte, Vue, or any other web framework, and then I'm gonna run everywhere. I think except for, oh really? Okay, so it also runs Android, and I didn't know about that. Android and iOS. Wow, that's surprising. That is very surprising because I'm writing another application called RomiDev using Flutter and Dart language, and it's cool, but man, using Rust should be very, very cool too. Okay, they integrate with Swift and Kotlin. Makes sense because Swift is used for Mac OS, so it should be easy for iOS. Kotlin, yeah, Kotlin is a little for, maybe it's not too much, have too much support. Anyways, and that application, because it's desktop, I need to test in Linux. I need to release in Linux, Mac OS, and Windows, and it's too much. And people don't like to download stuff anymore. If you are on YouTube, just watching some videos like that video, you want like copy the link and paste somewhere and get the result. Even if that result takes some time and you get a notification by email or something, you don't want to download stuff. You don't want to keep in update stuff. You don't want that stuff break and you need to update to resolve the break. And as developer, that also it's a nightmare, right? Mainly in my case that I don't have Mac OS and I don't I don't have um I say Mac OS in the cloud to be using for testing. Now I discovered that it has a way to do that, and I'm using for deployment. But even like that, it's very tough to keep in cross-platform alone. So I give a step back and said, why not create an Elixir, some worker that act as a proxy? Because the whole problem, yeah, I forgot to say that. So the problem, before talking about solutions, talking about the problem. The problem is the YouTube blocks IPs from servers. So you cannot run downloaders from YouTube from servers. And the only way you can do that is from residential IPs, because they cannot block residential IPs, otherwise people cannot watch their videos, right? So based on that, I need kind of residential proxies, and I start thinking, okay, I just need to pay for residential proxies and make my server application, but I don't want to rely in servers in residential proxies pay, because they also measure bandwidth. So if you have a lot of downloads happening, they're gonna increase the cost. So the alternative was create a Chrome or browser extension that I also did in the past. It's a nightmare, and for cross, and you have a lot of constraint as memory available, space in the disk, and a lot of stuff. And I want people download videos with unlimited length. So if the video has 9 hours, they need to be able to download. So okay, let's go to desktop then. And I started doing the desktop. It was beautiful, works magically, but to give support, it's terrible. So I give a step back and said, okay, let's go do a little worker that's gonna act as proxy. And I'm gonna use Elixir because I'm learning Elixir, and that's the best way to learn something. Of course, I'm learning Elixir with using AI, so that's a kind of problem, right? Because nobody knows how to learn a new language using AI. So also I'm figured out how's the best way to learn that. So what I ask for Cloud here, so that's Cap2 worker. I have the application, right? It's the module, and the impl here is kind of override in Java. It's kind of saying that you're take the function from that module and applying here in the using, because if I'm not mistaken, Elixir has like a meta programming too. It's kind of macros from Rust and maybe reflection for Java or decorator. I don't know. We can compare meta programming with that. No, decorator I cannot compare because they don't create code. Reflection, no, also we cannot do. Yeah, text meta programming is just I think maybe C++ has also meta programming. I don't remember. That's a nice question. That's a question I want to. What language has meta programming as Elixir and Rust? Python don't have. Zig maybe? No. Okay, Lisp, yeah. Lisp family. Yeah, Clojure. Don't know name. Julia. No, they don't. Yeah, Ziggy. Yeah, Ziggy has. Comp time is genial. Execute any code in compute time. Don't need syntax for macros. Yeah, comp time it's insane from Ziggy. And Scala and Haxe. I don't know Haxe. Yeah, Zig it's the language for that. Okay, don't lose track. And right, so we have the application. We have telemetry. Because I want to add Grafana. I used Grafana in the past. Very little, very little. You want to learn more about Grafanas and metrics. So here, can I put here? Wait, let me organize stuff here. That should be number 2. That should be number 2. That's number 1. And then we can take Grafana and put here. Yeah. So here I have the Cap2 worker dashboards, and you can see the workers process around 4 minutes already. They waste 15 credits. That should be that value in dollars. The average per jobs is that, and they have error rate here, so half succeed and half had a problem, right? And we have total jobs, and that's true because that's running for 14 hours. Here's the memory used, and the bin memory is 64, and the process count and the QE depth. I think it's the QE is the jobs, because what I do is people gonna get in the website now. Can put the link here so I can demonstrate that to finish the live, because that's too long already. But here I have, let me copy that one. Yeah, I can go here and add and what's the fila English equiwi, and I should be receiving a notification here if that's running, and also should be seeing some updates here. Yeah, this said it's downloading. Yeah, upload complete just now, sending, waiting for transcription. Yeah, that one has got timeouts, that got errors, but that one it's sending, so it said it's downloading. Then they're gonna send to modal, it's another server. That I use infrastructure as code. You see it's running the containers here. So we have the upload worker. Yeah, you see there, it's ready to use, transcription ready. They create a transcript first, and then they start another process called chapter generation. So I did the upload because that one it's already in cache, because I create cache, right? Because I don't want to waste money. So they're gonna give okay, then update here to 3. Yeah, so we have 32% now error. We have 3 jobs. Should we have the total now and the credits average, and so SLA in last 2 minutes is no data. I think because it's not working correctly, it's not sure, I need to check. And here the time, the job duration, right? So the P50 or 50% of people is getting 45 seconds in average, and 95%, oh, it means a lot of people, it's taking 58, right? Wait. Yeah. In here, 99, 59. I think I'm reading correct, right? Yeah. Metrics not my strong. I'm still learning. So download and upload latencies is taking 30 seconds. So let's refresh that. Okay, let's close the out. Gonna be cool see the observer for, I don't know. I think the cool to see observer from the other project I created, the flight reservation. So yeah, P50, it's half the jobs getting 45 or less, and 95% the jobs get close in 5 or less. That don't make any sense, Mick. Why? Oh yeah, it's correct. Wait. No, that's not right. How half it's finishing less than 45, and oh no, it's right. Yeah. So half in 45, and then the other half can be around more and more. So most of people is taking 1 minute, and that's gonna be increasing because I send the little videos. Yeah, he said that it's consistent. The difference between the two, it's little, and SLA, it's inside the targeted 2 minutes. So probably that's why it's not, we're not sending some SLA data here. I think they need to fix that one. Oh, my camera, how is, oh, my camera is dead. Time to time I need to power on the camera. Sorry for that. I forgot to keep my OBS there. So depending on, I should be asking for English. Okay, you're gonna check in Prometheus and Grafana. They configure something wrong here. The user rate. Rate need multiple points of data along the time. Need to process more on job to generate data. So they're gonna test again with the same video I did here, just to generate the data and check if the fix works. Wait, they didn't fix, right? Ah, they test here. They did a query here. Yeah. So yeah, so I create all the stuff here. That's the flight reservation project. That's the flight. They have a clustering. That's a kind of more complex, but each seat on the plane is a process, and the results of the test was very, very cool, very, very insane, because we locked the seat. It's kind of the lock concept from reservations, right? Where you don't let other people take your seat until you confirm the payment inside of timeout, right? You need to let user choose and go to next step. In the next step, you lock for 5 minutes and wait for payment confirmation. Otherwise, you release the seat. Right. And yeah, here we can like look up for the seat, and they have all the supervisors to handle the process. And here we are, I think, using, I'm not sure we are using Gene servers, no? No, I think it's not Gene server. Starlink is from Gene server. No, Starlink is from supervisors, right? Yeah, so we have a supervisors. Yeah, no, it's Gene server, right? Once the dynamic supervisor is running, you can use it to start a children on demand. Give the example of Gene server. No, yeah, I think it's the, oh, that came from the agents concept. Maybe. Do we start? Jane start. Oh, start a mode case. Wait, where? Erlang. Oh, that's Erlang. Ah, I don't have Erlang plugin here. I'm using Z IDE. It's very cool. Writing in Rust very fast. Extension. how I use extension. No, it's not that. Erlang. Okay, let's just check if that's official. Yeah, that extension. Okay, it's official. Just in case. All right, should be installed. Yeah, that's Erlang now. Very nice, right? So start. Yeah, Erlang it's very confusing. Do swap, spawn. And we don't have way to go. I think it's that native, maybe. Yeah, I think it's native, maybe. Yeah, so the supervisor is using Gene server here. Yeah, then I have an application, I have dashboards, I have the demos, the concurrence demo. They have a I did some wait 1 second. Where is the scaling here? So how much load that can handle and how much they're gonna be the cost. So for 300 monthly in Amazon servers cloud, now that's compare for my laptop. Yeah, that's my if a laptop or server with 8 core, my case it's 12. I think they did into my 12. No, I did it. Yeah, they said here in the peak how much flights, how much seats and average, total seats. The flash sale need to 5,000 reservation attempts per second and 30 minutes. Normal peak 1,000 reservation attempts per second, between 2 or 3 hours. And capacity here 18,000 OPSEC. Peak needs 5,000 OPSEC. In my laptop the utilization was 6%. Oh, they said they're gonna use 6% and margin and costs. Yeah, even they said they can use that in Raspberry Pi. Yeah, 1 million. Of course, the bottleneck, the limit for that scaling, it's not our application, but it's the payment system, right? Because we need to wait for the confirmation of the payment before make the reservation. But the lock and the unlock are gonna be very, very fast. As soon people don't confirm the payment, they can do the unlocking. And of course, that's the naive implementation, because in real world, we need to lock for more time based on the average time that payment happens, and also deal with multiple payments that also sometimes happen, where 2 people paid, but only 1 people can have the seat. So something I see they doing, it's like they, after people choose the seat and go to the next step. Also that also happen in the theater or in cinema. They like put a timer for 30 minutes there, like counting down. After that you can lost your seats. All right. All right. Survive single server failure. Yeah, I did. Yeah, I did a lot of tests here, but I did something very cool. Was I try? I'll try start the capture worker, and then I finish because I did. They did some warning. I want to check the warning, but they restart automatically for me and keeping working. It was very cool. Yeah, then I have the downloader. My worker is connected with Supabase and the modal to check stuff. It's very cool, very simple. Here the notifiers, another module, another Gene server. So the Gene server, they connect, if I remember correct, they connect easily cross process using cast. I think it's cast is synchronous. No, it's asynchronous. Without cast a request to the server without waiting for response. And we have, I think it broadcast. I don't remember. I think I don't use sync here. PowerShell. Yeah, because I asked for be multi-platform. Huh. I don't think that works. Maybe works. Anyway, yeah, it's late. I need to sleep. I need to wake up early. But I can show more about how I'm studying. Basically, I ask for Claude explain in the comments and also write a lot of docs about that, about the architecture, for example. That one I already has, and that one too. So was missing the GUI and update the front end, and was very surprised and fast to do that. And the cool stuff about Elixir to finish is the process using actor model communicate between process, right? Sending messages, but the Beam VM allow you deal with process. For example, I can have what it is downloader, for example, casting was here's a task, for example, async concept task async spawn a process that executed function in parallel. We can wait for result when task await or receive via messages. Here he didn't wait, right? They just return. Only process if not task is running. Yeah, if I'm not crazy, I think that's for receiving message, right? Invoke to handle all the other messages. Yeah, so you can have a lot of handle info, each one with a signature from the message you're gonna receive. So that communication happening cross module or processes can also happen cross clusters and transparency. I can run 2 nodes. I was testing something like that for the flight. So here you can have 3 nodes. Each node has some total seats, and together they have all that. And people, if people call any nodes, they're gonna act as like load balancer. They're gonna check who can has the other seats and passing the messages very fast. It's very cool. instead having a load balancer. We're gonna have load balancer anyways, but part of the complexity it's due automatically because you're gonna write a code that can message another node that have seats available. Of course, for performance, the ideal is that the load balancer also has the information, but because the process is so fast, I think it's more easy to avoid in that specific case, right? Here they test cross nodes performance. They test 10,000 requests. Local calls was 3,000 and remote calls 6,000. The throughput 35 operation seconds. Still fast with RCP. Yes, exactly. They are talking to get what remote proceed call, and it's still very fast. The average latency it's 0.30 milliseconds. It's insane, right? That's insane. For me, that's easy. Okay, it's running the node in the same machine, but it's still insane because it means the latency added here from network gonna be basically the network, nothing more. If you have a little ping between the servers, it's only that. I'm gonna test that in the different clouds in regions to see what happened. I'm gonna deploy somewhere. I have a VPS, so I can deploy one in my VPS, another in Amazon, another in my computer, right? So we have 3, and then I can test. Here the distribution test. So they test 100. One is 100,000, right? 100,000, and here they test the fairness score. It's perfect distribution. Each node receive the distribution of the load. Okay, yeah. All right. I want to show the docs that okay, that's teaching me about Prometheus and time series. I have another, I think. I don't have another. Maybe my readme. Yeah, he explaining for me the concept, what the task is of the Jane server. Also here explaining about the configuring the runtime. Also, I watch a lot of videos, but I need to go because it's midnight. Thank you for who watch or gonna watch later, and see you next time. Oh, get better.